Hello and welcome back. Today we are going to take a look at solving quadratic equations using the quadratic formula. So let's get started. So first let's remember that our quadratic equations are in the form ax squared plus bx plus c is equal to 0. And our quadratic formula is given by negative b plus or minus the square root of b squared minus 4ac all over 2a. The first thing we want to take a look at is this area under the square root. This is what we call the determinant. And if we take a look, b squared minus 4ac. Now, because it's a square root sign, if this number, whatever it ends up equating to, if this number is less than 0, meaning it's a negative number, what that means is we'll have the square root of a negative number. Now that's an imaginary number. So we can add 4ac to both sides, and we can say that if b squared is less than 4ac, this means that when we use our quadratic equation, we will get two imaginary numbers, or two imaginary roots, or our results, our x, will have two imaginary. Now, by the same token, if our b squared minus 4ac is greater than 0, that means it's positive. By the same token, if b squared is greater than 4ac, we will have two real solutions, because we'll have the square root of a positive number, and that'll give us a real solution. And finally, if our b squared minus 4ac is equal to 0, or b squared is equal to 4ac, well, we can see that when we have the square root, if b squared and 4ac are the same, they will end up canceling each other out. That's like saying we have some s minus s, and that will give us the square root of 0, which will give us 0. So in our equation we'll have some negative b plus or minus 0 over 2a. Well, negative b plus 0 is still negative b minus 0 is still b. So in this case we'll just have one real solution. So this is something that you can kind of look at and see if you're on the right track, knowing whether you're going to be looking at imaginary solutions, real solutions, or just one solution. So let's go ahead and look at an example. X squared plus 8x plus 12 is equal to 0. So here our a is just 1, and there's nothing in front of the x. That's the same as 1 times x squared. Our b is 8, and our c is 12. So we're going to use negative b plus or minus the square root of b squared minus 4ac all over 2a to solve this. So when we use a formula, all we have to do is substitute in. So our b is 8, so we have negative 8 plus or minus the square root of b squared, that's 8 squared, that's 64, minus 4 times a is 1, times c is 12, all over 2 times a, which is 1. So simplifying that out, that's going to give us negative 8 plus or minus the square root. Well, 4 times 12 is 48, and 64 minus 48 is 16. So this is going to be all over 2. Now, because our negative 8 is divisible by 2, sometimes it's tempting to just reduce this and say negative 4 plus or minus the square root of 16. But this is not correct. And the reason it's not correct is we can do this. We can separate it to negative 8 over 2 plus or minus the square root of 16, but this is also over 2. So we can't forget to do that. So if you do want to make it negative 4 and reduce it, that's totally acceptable. But you also have to remember to put your radical, to put your square root over the 2a as well. So let's go ahead and continue. This will give us negative 8 plus or minus the square root of 16 is 4. And again, this is all over 2. And this is going to give us our two solutions, which is negative 8 plus 4 over 2 and negative 8 minus 4 over 2. So that's just going to give us negative 4 over 2, which is going to give us negative 2. And this is going to give us negative 12 over 2, which is going to give us negative 6. And these are our two solutions. X is equal to negative 2 or negative 6. And we can then plug that back into our original equation and see if that works. So our original equation is x squared plus 8x plus 12 is equal to 0. So if we put negative 2 into this, negative 2 squared is 4. 8 times negative 2 is minus 16 plus 12. Adding our positive terms, 12 plus 4 is 16. We get 16 minus 16, and that is equal to 0. So we see that negative 2 is a solution to the equation. We can do the same with negative 6. And that'll give us 36. 8 times negative 6 will give us negative 48 plus 12. Again, adding our positive terms, that's 36 and 12. That's going to give us 48 minus 48. And that does, in fact, equal 0. So we can see that our solution, x is equal to negative 2 or negative 6, both are correct solutions to this quadratic equation. And we found it using the quadratic formula. So let's take a look at another one where we do not have 1 as our a, and that's not in the traditional form. So we want it to be ax squared plus bx plus c is equal to 0. So how we do this is our a is going to be 5. We're going to have 5x squared, and then we want to plus our b. There's nothing in front of here, so our b is going to be 1x, because 1x and x is the same thing. And then again we want to plus, and how we do this here is we'll make c negative 2. And so now we have our a, b, and c, which you can see in the green. So we're going to put it into our equation, negative b plus or minus the square root b squared minus 4ac all over 2a. So we can see that our negative b is going to be negative 1 plus or minus the square root of b squared, which is 1 squared, that's just 1, minus 4 times a, which is 5, times c, which is negative 2, all over 2 times 5, which is our a. This is going to give us negative 1 plus or minus the square root of 1 minus, well, 4 times 5 is 20, and 20 times negative 2 is going to be negative 40, but minus negative 40 is really plus 40 all over 10. And this will give us our solutions of negative 1 plus the square root of 41 over 10 and negative 1 minus the square root of 41 over 10. And these are our two solutions to the quadratic equation. Let's try one more. Suppose we have 3x squared is equal to 6x minus 1. Well, again, we want this to be in the form of ax squared plus bx plus c is equal to 0. So we're going to use algebra to move all of this to one side. So 3x squared, subtracting 6x from each side, we get minus 6x, and then adding 1 plus 1 is equal to 0. Now we're in this correct form, and we have our a is 3, our b is negative 6, remember this is plus minus, our b is negative 6, and our c is 1. So let's put that into our formula. We have negative b, though that's negative 6, plus or minus the square root of b squared. Negative 6 squared is still 36, minus 4 times a, which is 3, times c, which is 1, all over 2a, which is 2 times 3. Well, negative 6 is going to give us a positive 6. So we're going to have 6 plus or minus the square root of 36 minus, well, 4 times 3 is 12, so that'll give us 12. And 2 times 3 is 6. Now again, remember, it's tempting to just cancel these terms out, but we can't do that. We have to remember that the 6 divides both the 6 and the square root of 36 minus 12. So we get 6 plus or minus the square root 36 minus 12 is going to give us 24 all over 6. Now, while 24 isn't a perfect root or perfect square so that we can take the square root of it, we can look at it as 24 is equal to 3 times 8, and 8 is equal to, so this is 3 times, and then 8 is 2 times 4. And 4 is a perfect square. So we can look at this as the square root of 3 times 2, which is 6, times the square root of 4. The square root of 4 is 2, so this will give us 2 square root of 6. So our answer is going to be 6 plus 2 root 6 over 6, and 6 minus 2 root 6 over 6. Now we can think of this as 6 over 6 plus 2 root 6 over 6. These 6's just become 1, and this cancels out to be 1. 2 6 is the same as 1/3, so you can write 1 plus root 6 over 3, and by the same token over here, 1 minus root 6 over 3. Now, when we have complicated solutions like this with square roots and such, we can check our answer still. It's a little bit more difficult, but we can check it, and I'm going to run through it really quickly. So we have 3x squared minus 6x plus 1 is equal to 0, or you can even use the original equation, which is 3x squared equals 6x minus 1. You can use either one to check, and if you're concerned that maybe you did your algebra wrong, it might be better to use the original equation to make sure that your algebra is correct. And we got solutions of 1 plus root 6 over 3 and 1 minus root 6 over 3. So the first thing we'll need is x squared. So let's try the first one. If we have 1 plus root 6 over 3 times 1 plus root 6 over 3, we have to FOIL this. So we get 1 times 1 plus 1 times root 6 over 3, which is just root 6 over 3, plus 1 times root 6 over 3, plus root 6 over 3 times root 6 over 3. Well, root 6 times root 6 is just 6. And 3 times 3 is 9. So that's our x squared, and that's the same as 1 plus 2 root 6 over 3 plus 2 thirds. So we have 3 times that quantity, 3 times 1 that quantity, which is 3 times 1 plus 2 root 6 over 3 plus 2 thirds, and we want to know if that's equal to 6x, so 6 times our x, which is just 1 plus root 6 over 3, minus 1. Well, distributing the 3 to all of these, we get 3 times 1 is 3, plus the 3's will cancel out, you get 2 root 6, and the 3's will cancel out, plus 2 is equal to, distributing the 6 plus, and 6 divided by 3 is 2, so that'll be 2 root 6 minus 1. And we want to know if these are equal. So 3 plus 2 is 5, so we have 5 plus 2 root 6, and 6 minus 1 is 5, so we have 5 plus 2 root 6. So we can see that these are in fact equal and that that is a correct solution to our quadratic equation. And you can do the same with the one minus root 6 over 3 to check as well. So when it comes down to it, all we're really doing is we're taking this formula that we are given, and it's really good to memorize because you'll use it a lot in the future, and we are just going to change our quadratic equation to look like it, to make sure it's in the form ax squared plus bx plus c. Then we're going to use our a, b, and c, and we're just going to plug it into the formula and solve. And of course, as always, you can use your solutions to plug it back into your original equation to check and make sure they are correct and they are solutions. In the next video, we're going to combine everything we've learned in these last few videos and take a look at some general problems and what technique is the best way to solve it. Thanks for watching, and I hope you tune back in.